Okay, let's begin this new topic on carbon footprint reduction for the manufacturing industry. And our focus is using graphical method for the reduction of carbon footprint. Okay. So we skip the part of for energy graphical method for energy. So let's circle back to that after the carbon footprint. Okay. So in the past few years, companies and corporations are doing their best to reduce their carbon footprint, especially in manufacturing processes. They're making their processes and the products more greener, quote unquote, and more sustainable. And this is the main agenda for carbon footprint reduction. So in the slide, you'll see that all consumer products have carbon footprint contributed by first the raw material and second the utilities in the production of the consumer product. Um, so when a consumer receives the product, the source of the carbon footprint will be these two, okay, the material and the uh, utilities. And usually the utilities is just the bulk of the carbon footprint would come from power and steam production. The power, when I say power, it's the electricity, and they usually purchase this externally. Well, for the steam, it's usually produced within the manufacturing industry. We have three different scopes for greenhouse gas emissions. So this is a parang international definition of scope 1, 2, and 3 greenhouse gas emissions. So for scope 1, this is the emissions associated with that of the company's production and internal operation. So ito yun. So it's from process emissions, company vehicles, research and development. Okay. So those are the scope 1. So it's very these terms or the uh definitions are very common. So I hope that you will remember this scope 1, 2, and 3. For scope 2, um these are coming from electricity, heating, and cooling. Okay. And then still within produced internally. Okay. And then the rest of the value chain, so these are the external um contribution. So these are so examples are traveling, transportation wastes, and end of life treatment, etc. Okay. So those are scope 3. And we can see here that the first two are upstream activities, while the third is reported by the company, and the last is downstream activity. So usually, this is the only commonly reported by the company. So reported to the government or the environmental bureau. But take note that carbon footprint would also come from the rest of the value chain. So they also have to consider the rest of the value chain. Okay. So the next slide would um, we would introduce a graphical method. Okay, again based on composite curves, sorry, that can be used to visualize the carbon footprint reduction, and its reference or its origin are actually these two papers. Okay. So the main methods come from these two papers that I'm showing on the screen. Okay, let's discuss first case 1 because there are two cases. In case 1, the situation is the external carbon footprint is less than the internal carbon intensity, not footprint. So when I say intensity, it's the CO2 emission divided by the economic value, okay, of the process. Okay, so it's emissions, or say the measure is tons of CO2 per dollar or per euro. So that's carbon intensity. So case 1 is where the external intensity is lower than the internal. So here, as you can see, the first line here refers to the external footprint, while the second line, the blue one, is the internal footprint. So again, let's define the what's external and internal. Okay. As mentioned in the previous slide, external would come from outside the manufacturing company, while the internal would come from or will be generated internally in the manufacturing company. Okay. So as long as the footprint are generated and brought into the products, we can make use of this tool to visualize the carbon footprint intensity and also to visualize its reduction opportunities. So again, the y-axis is the CO2 emission, while the x-axis refers to the economics cost or the value added. Um, so how can I say that the external carbon footprint or external intensity, carbon footprint intensity is lower than the internal? Okay, because of the slope. Okay, the slope of this line here, which refers to the internal carbon CF intensity. So let me just use the acronym CF for carbon footprint. Steeper. Okay, this one is steeper compared to the external. Therefore, this CF intensity is larger. Okay, so a steeper segment simply means that its intensity is higher. So therefore, the opportunity to reduce the carbon footprint would be in this part here in the um, internal footprint. Okay. Say for example, we want to reduce the carbon footprint intensity by 10%. Okay. So this is represented by this line. So assume that this is this gap right here is 10% reduction. Okay, so this represents 10% reduction. So that would be our demand composite curve. Kasi yung kanina, yung carbon footprint intensity would be the source. The demand would be our target reduction. Okay, so um, then we need to reduce the slope of the higher footprint segment. Okay, so we need to reduce the slope um, to reduce the carbon footprint intensity. So we can do it by doing that. Okay, so did you notice we reduce the slope? Okay, so that's one way of um, reducing the CF intensity. Okay, the next case is a situation, okay, wherein the CF intensity of the external footprint is greater than the internal CF intensity of the internal footprint. So it has a steeper slope. Okay, so uh the opportunity, okay, so the opportunity would be to reduce this external footprint because it has a higher CF intensity. So how do we do that? Say we have a target to reduce the intensity by 10%. Again, imagine that this demand curve represents our target to reduce by 10%. So we can do that by, okay, sliding this line right here. So as you can see, the external footprint is reduced and we're able to meet the target. Just like the previous slide, no, we're able to meet the target. So basically that method right there describes the graphical technique for reducing carbon footprint in production in the manufacturing industry. Okay, I think this is the last slide. So so I forgot to mention that this in case one, okay, this should represent the total emissions. Just like in case two, this would represent the total emissions. And as we reduce the CF intensity of the process by shifting the graph of the internal footprint, you'll notice that it means that for case two, we are increasing the internal footprint and decreasing the external footprint. Okay, so yun. Okay, again, this method is proposed by the following authors, Tijan et al. In 2010. This is the last slide for the introduction of the methodology. Let me move on to the next slide. Okay, but first, I'll have a quick break lang. I'll pause the recording. Okay, let's proceed to case study 1 or an example of applying the method which I discussed earlier on biochemical production. So this one is on wait lang. Okay, so for this example, we will look into Tongkat Ali production. Are you familiar with Tongkat Ali?
No po.
It's a herbal extract. Okay. So the process is like this, as you can see on the diagram. First, the Tongkat Ali is placed inside the extractor with the ionized water, and then after that, the extract plus fiber will be filtered. Then there will be a holding tank, and then the liquid portion will be sent to the holding tank and then to the spray dryer. Okay. So here the water is removed and we get a dehydrated extract, water extract or final product. So that's the process for Tongkat Ali production. To give you a background, this is Tongkat Ali. It's actually the root. Okay. This is the scientific name. It's used as aphrodisiac, tonic, anti-malaria, antipyretic. It's can be the roots can be taken orally, and scientifically it's found to be anti-cancer, antioxidant, and it's a male aphrodisiac. Okay. And these are some pictures in Tongkat Ali production plant. First, the roots are sliced, okay? And then it's put inside the extractor, as mentioned in the diagram. And then, um, so here the essence is extracted, and then it's sent to the drying operation. Okay, so there are two ways: freeze dryer or spray dryer. Okay, operation. And the final product would look like this, a powder. this would show an equipment that produces tongkat ali. On the left is the extractor, and on the right is the spray dryer. So the detail of the operation is described in this paper. Um, so it's a process simulation of the operation of Tongkat Ali water extract production. Okay. So again, dalawa lang yung major steps ng process, which is extraction and then drying. Tapos packaging na. But this just revolves between these two major steps, extraction and drying. So by the way, it's sold in capsule form, just like herbal supplements. First, we look at the material and consumption cost. So this is from the plant. Okay, this data is from the plant. So as a process engineer, okay, your role is to gather this data and then summarize it in a table. Um, so the reason why we're doing this is, remember, we need to plot the composite curves. Okay, so on the y-axis is the carbon footprint, and then on the x-axis is the economics. So um, that's why we need to compute for both the carbon footprint and the economics. So first we focus on the material consumption and cost. So we add this row right here just simply adds, okay, the material use, and then um so converts it to per month basis. Our um basis is 1 month, okay, and then finally, okay, given the unit price, okay, this is specific for this production of Tongkat Ali, okay, then we'll get the total cost per month. Okay, so just simply the unit price is dollars per material. So simply multiply this column here with this one would give you the total cost per month, and then add everything, you'll get, okay, the total raw material cost. Okay, so far is it clear?
Yes po.
All right. So as you will remember in our introductory slide, 'di ba, we have two sources of carbon footprint, the material and the utilities. Under the utilities, we have the energy consumption, which refer to the power or electricity and steam. So now that we're done with the material costing, let's move on to the energy costing. So basically, just get the data from the production. Um, for example, your data is in megajoules per month. Then given the price of electricity, then you can calculate the cost of electricity per month for the production. And then okay, and then for the steam, the same way, just calculate the cost per month and add the total energy cost. Okay? Okay. So this is for the production of, specifically for this amount of uh Tongkat Ali root chips. So it's our basis. Okay, functional unit natin is per month. Okay, so this is the basis. So we're done with the material and energy costing. Let's move on to carbon footprint costing. Okay. First is for the materials, for the raw materials. So we have Tongkat Ali, and so that's our organic material, and then we have other inorganic materials. For Tongkat Ali, okay, um, So by the way, why is it 31,667? Hmm. Well, here it's 38 kilograms. So I need to check on this. This is per year. So let me divide. Just get the calculator. Wait lang. 38,000 divided by 12. Yeah. So this is per year and this is per month. Okay? Per month, this is our Tongkat Ali consumption. Um, so for the carbon footprint, the main contributor is usually the transportation. Uh, so other things like using say agricultural machinery for extracting the or for getting the Tongkat Ali root is is assumed to be insignificant compared to the transportation. Okay. And 600 kilometers, the distance is 600 kilometers from the farm, Tongkat Ali farm, to the production plant. That's quite far. Okay. And then get the data of the carbon footprint of the heavy duty or the truck that would load or deliver the Tongkat Ali. And this is approximately this value. But of course, it would depend on your specific scenario. So this is just for the Tongkat Ali scenario. Okay, so you have the amount, you have the distance, and you have the carbon footprint index. Multiply that, and you will get the carbon footprint in kilograms per month for the Tongkat Ali alone. How about for the other inorganic materials? So this would refer for the others. So ito yung sa Tongkat Ali, and then the other inorganic materials would be water, chilled water, maltodextrin, bottles, and boxes. Um, so because of the data availability, they were lumped together and assumed that for every 2 kilogram of carbon released, okay, the ratio is, and the cost is 1 US dollar. Okay, gets ba? So uh, for every dollar of consumption of these or inorganic materials, the carbon footprint is 2 kilograms. And that data is from the OpenLCA database. Okay. Again, when you're going to do this on your own, it's your responsibility to find your own data specific to the process or production that you are looking into. So this is just specific for this scenario. And then okay, so we already have the cost of this other raw materials. Okay, let me check um if it would tally. Wait, I will um yeah, assume all materials are inorganic except tongkat ali. So basically, we add 6174, 61 plus 74 plus 759 plus 3161 plus 342. Okay? So the cost is 43, tama. This value nakuha so far. And then multiply it with this 2 kilograms. You would get the carbon footprint for all the inorganic materials. So far, do you have any questions?
Wala naman po.
Okay. So again, ano, simplifying assumption lang to. Okay, this is just a simplifying assumption. So we now add the two values to get the total CFP for all the raw materials. And that's 9 megatons of carbon dioxide per month. Okay, so let's move on to the CFP calculation of energy. Um, So for the internal steam production, assume this value for steam carbon intensity, okay, 0.17. And then this data comes from the power from the production plant. So multiplying these two value, you get the CFP of the steam. Next is for the power. So again, this is the electricity consumption, and we assume that this is from external. So can you imagine we have a production plant, so their electricity, say for example, comes from Meralco, but they produce their own steam. Okay. So for this specific study, this is done in Malaysia. Okay. So this is the energy mix of Malaysia: natural gas, coal, hydropower, oil. Natural gas is the highest, 50%. So sa atin, in the Philippines, coal is the highest at 50% or around 49%. But since the case studies in Malaysia, we use the energy mix of Malaysia to calculate for the index, okay, carbon footprint index of their electricity. Okay? So, um, kasi this is what happens, diba? When the country produces electricity, it comes from different sources, not just natural gas, not just coal. So it's a mix of different sources. That's why we have to calculate for the overall. Okay, gets ba yun? Okay. So basically, um, given the carbon intensity of these fuel types, we now are able to calculate. Okay, so simply by multiplying this one by the percentage, diba? Percentage, we get the carbon footprint for each of the um energy source, and then add them together to get the overall. So para saan to? Paano natin gagamitin? We need that, okay, um because if we're given, okay, the power consumption or electricity consumption of the production plant, okay, the given value is in terms of energy or kilowatt hour. Okay. So multiply with this overall carbon footprint uh, index, okay, you will get the carbon footprint of the electricity per month. Okay? Nakuha ba?
Opo.
May question? So just multiply this, convert this to kilowatt hour, and multiply the value from that with this to get the. So it's like doing dimensional analysis over and over again. Okay? So adding the two would give you the CFP for energy. So ano na yun? Combined steam and power. So now we make this summary table. Okay. This is summary table we'll be using to plot our composite curves. First is the um, material, and then under energy we have two electricity and steam, where electricity is assumed to be external. Okay. So um here is the actual consumption, kilograms, electricity megajoule, steam is in terms of kilograms. This is our calculated value or cost, okay, economic value uh, in the previous slides. And this is our calculated CF, carbon footprint, okay, in the previous slides. So we add them, get the total. So next is we assume what is the target. So this is set by the company, the decision makers. What is the target? Say, for this example, we aim to reduce by 10%. So multiply this value by 10%, we get about 1.4 megatons of reduction. So we want to reduce the carbon footprint of the company by 1.4 megatons of CO2 per month. Okay, so now we proceed with the carbon footprint composite curves. We draw them from on the y-axis, it's the CO2 emissions or the carbon footprint. On the x-axis is the economic value. So we simply draw, okay, first let's start with the material base segment. We simply draw the values here. So $14,000 tsaka 9. Ayan, so ito yon 9 and 14.5 thousand dollars. Next is the energy based. So it's the addition of these two. Okay, this two. So ayan, pinagsama na yung electricity and steam. So between case 1 and case 2, nalimutan ko ano ba yung case 1 and case 2 kanina. Ano yung, when external is lesser, okay, that's case 1. Pero ito kasi, um, in, we're focused on material and energy, not the external and internal. Pero later we'll um, get into that. So dito, the one with the steeper slope would mean higher intensity, like just like yung discussion kanina. So obviously that's the energy based segment. So now we plot our demand curve, and this is the target reduction. Okay? So the target reduction is 10%. Ito yan. So 1.4, okay, 1.4 reduction. Um, so we have to achieve this. And since this would have a steeper curve, a steeper line, itong energy base, we focus our efforts on this segment here, which is on the energy based. Okay, may questions so far? We focus our efforts, our reduction efforts on this segment here. Yeah, so much steeper, higher intensity. So the next step is to decompose. Okay, when you say decompose, diba, break into their smaller parts. We decompose this segment into the, ayan, ito na, into their smaller parts, which is first is external, this is the electricity, and internal, this is steam. Okay, so how do we plot this again? Just use the data, okay, ito, individually. So, kanina do sa first graph kasi, they were combined in one segment, and now we separate them into their separate segments. So, external and internal. So, here, this is case, I think case 2. Case 2 is steeper yung this is case 1. Steeper yung internal segment. Okay, so case 1, um, and then we also plot our target. Okay, so we plot the 10% reduction, which is 1.4 megatons of carbon footprint, carbon dioxide, carbon footprint per month. So yeah, so it means that our source should be below or katapat lang, uh, below this demand composite curve. Okay, so how do we do that? Okay. Again, since this internal segment is steeper, we can focus our efforts on this internal segment. So that means we have to completely remove this internal segment, okay, and part of the composite curve. Okay, part of the external segment. Okay, kuha ba? To meet the carbon footprint intensity. Okay? Again, Bakit? Kasi based on our target, hanggang dito lang dapat yung sa horizontal line na to, yung carbon intensity natin. However, current state ng source composite curve, above siya nitong horizontal line. So, we have to completely remove this and part of the external segment. Okay? But it's impossible to not use steam because it's a requirement in the production of tongkat ali. So, what can we do? Okay, what can we do to meet our target? So, this is a process diagram of tongkat ali. Um, as you can see here, for the uh, using, okay, this amount of tongkat ali would only, the product would only be just 28 kilograms per month. Okay? So, out of the 3,000 plus na fiber, okay, ay sorry, 3,100, nasa na yung tongkat ali? Ito, 3,100 kilogram na root, everything is actually residue. Itong TA fiber, ito residue or waste. So, these are just the waste. Tapos, ang production is just 3% itong TA powder. So, let me zoom on that. So, this is just the product, the TA powder. The rest are waste. So, we can use actually the waste to fire our um first there are two options na for power consumption and then steam consumption. Okay? Option 1 and option 2. Yan. So we can use the uh, biomass waste right here na ang laki-laki kasi nga 3% lang yung Tongkat Ali product. Okay, for either firing our power consumption or steam consumption. So let's look at option 1, which is power generation or electricity generation. So if this is our target reduction 1.4, so that means that if we are consuming 3.5 megaton, sorry, not consuming, if we are releasing 3.5 megatons of carbon dioxide per month because of power generation, so that means, okay, we only need to release this value. Get ba? Kasi nga ito yung reduction. So we have to reduce our original 3.5 to 2.1 lang per month na carbon dioxide emissions. So if our external, okay, so we calculate our external electricity supply, okay, based on this um remaining value, and that would be 12,147 megajoules. So dapat if we want to reduce by 1.4 na emissions, this is the uh, power supply that we can use externally. So therefore the rest should be supplied by the biomass waste. Okay? Nakuha, Crystal, may question so far?
Wala. Wala naman po.
Okay. So meaning we should produce this amount of energy using the Tongkat Ali waste. And assuming ito yung calorific value of Tongkat Ali with the moisture content of 50%, and assuming that our power plant, okay, so power plant na sa loob ng production company, production manufacturing industry natin would have 40% efficiency doing dimensional analysis. So ikaw na yung mag dimensional analysis. Um, actually, with this residue, amount of residue, this is the um, power we can generate per month. Okay? with this residue. So it's larger than the um our target na our target internally provided power supply. So meaning we can actually um supply our own power using the biomass waste. So more than sufficient to reduce the 10% by 10% overall CFP or carbon footprint. Okay? However, in the first place, the question is, do we have a power plant inside our production industry or manufacturing industry? Wala. Kaya nga sila bumibili ng electricity sa Meralco, say for the Philippines, or sa kanila sa Malaysia, whatever um, seller of electricity they have. Kasi wala silang power plant sa loob because it would mean a significant investment in the power generator. Okay, so sayang, um, okay sana, 'di ba? It can provide the power and as this significantly reduce, okay, the um CFP, okay? Significantly reduce the CFP. Okay. So that's not the scrap let's scrap that because it when you present this to the higher ups, they would just, laugh because, huh? We're going to buy this amount of, we're going to buy billions or siguro billions or millions of dollars of equipment para lang ganyan. So, they would always think about money, of course, cost saving, ganun. So we look at option two, which is steam generation. So steam generation. So now we try to see how much of the internal steam generated can be powered by our waste biomass. Okay, assuming our boiler sa steam generator has 70% efficiency and the heat content of the steam is this value and same assumption yung calorific value ng biomass waste ng tongkat ali waste is this one and also 50% moisture content. So converting the amount of solid residue or the biomass waste into steam production per month, um, this is the amount. Okay, so meaning um, we can entirely remove the internal segment. Okay, because our current steam usage is 7055 and because actually it can be provided using the Tongkat Alley waste. Okay. So by the way, biomass is carbon neutral. Okay, so it's okay to burn it compared to burning coal. Siguro ang current fossil fuel ang current fuel nila to generate the steam. So, however, it's not yet enough. 8.8% reduction lang. Okay, not 10%. Pero, it's good enough na. Acceptable na to sa higher ups. Okay? So, wait lang. Pause ulit. Crystal. Wait lang ha. Tayo. Alright. Okay, so option 2 provides 8.8% of CFP reduction. Although it's less than 10%, it's more economical compared to option 1. Okay? Oh, so uh, actually that's the last slide na pala. Do you have any questions?
Wala naman po.
Okay. All right. So that ends case study 1. Ay, hindi pala pinakita yung reduction. yung composite curves. Okay. So for your uh worksheet, actually your worksheet is just a repetition of uh what we discussed in class today. So let me share the Okay, so basically just repeat the process using the same case study that we discussed in class today. Ayun. Ayun lang, yun na mismo. Ito na mismo, teka. Um, ito na mismo yung gagawin mo. Ay, ito ba yun? Ay, oo. Okay, ito tsaka ito. So, i-draw mo lang ulit. Okay, so using this data, balikan mo na lang yung yung recording. Okay, so for now, let's stop the lecture there and proceed na lang next week. So now we move on to your reporting. Okay, I'll stop the recording now.